Welcome to the project demonstration of EV BMS along with charge monitoring and fire protection with SOC and SOH calculation. So here mainly we are using a lithium-ion battery pack which is of 11.1 volt of 2000 mAh battery pack. In this one, 3.7 volts batteries are connected in series. So the output of this battery pack is 11.1 volts. So our battery voltage and the current will be continuously measured by our PIC microcontroller, and the measuring data will be displayed on the LCD screen. So this is going to be the monitoring purpose. And coming to the controlling, whenever the battery voltage is less than the 8.5 volts, that's the threshold value, then the system will provide us the audible alert through the buzzer, as well as we can charge this battery pack in faster and slower charging. It's normal charging and faster charging will be done with the help of this electromagnetic relays. So single relay on nothing but slow charging, and two relays on nothing but fast charging, and this can be selected from these push buttons. And the voltage and current will be measured with the help of these sensors. So this is a current sensor which is a series, and this one is the potential divider circuit to measuring the voltage of this battery pack. And also next is thermal protection, means fire protection. Whenever the battery pack temperature is crosses the 45 degrees centigrade, then the system will on this buzzer along with cooling fan to provide the thermal protection for this battery pack. And also continuously the system will calculate and displaying the SOC SOH values, nothing but the state of charging and state of health. State of charging, nothing but while we are charging the battery pack, if the battery pack voltage is increased according to the current ratings of this charging circuit, so we are using 1 amp charging circuit to this one, and if the voltage is increased normally, then the SOC value will be displayed near to 90 to 100%. Coming to the SOH, whenever we added the load, or if the battery voltage is drastically or rapidly discharged, then the SOH value will be affected. Means if it is not discharging like rapidly or normally slow discharging, then the SOH value is nearby 100 to 90%. And these details continuously monitoring on 16:2 LCD screen. And to execute these features, so for charging of the battery pack, we are providing 230 volts AC input. The power flow is 230 volts AC input to the transformer. So 230 volts AC will be stepped down to the 12 volts of AC, and that is input to this regulated power supply board, so which has a rectifier section, filtration and regulation. So here after filtration we will get 12 volts of DC output to this battery pack charging through this relays. And the next this 7805 will take 12 volts DC input and provide us the 5 volts DC output. So that is the operating voltage to our microcontroller motherboard. So once it get the 5 volts DC input, it start reading input from this current sensor and voltage sensor. Based on these two values, will display the status on this 16:2 LCD screen. And faster and normal charging purpose, two control buttons, and abnormal detected buzzer will be provided. And this one is a transistor board to on and off this fan whenever the temperature cross the threshold value. And based on this selection, this electromagnetic relays will be controlled to charging of this battery pack in faster and slower manner. So let us check with the demonstration. So once we on the power supply, so welcome message displayed on the LCD screen, and the battery voltage and SOC SOH values will be calculated and displayed on the LCD. As of now there is no load connected, that's why the current is 0 milliamps. So when we on this load, then the current is 1040 milliamps. As we are using the 1 amp of load we are using, that's why the current consumption will be displayed here. And after 20 to 30 seconds of duration, the SOC values will be calculated. SOH also will be calculated, displayed on this LCD screen. You can see these values. And to make the battery voltage low, so we are using this switch to make the battery voltage low alerts. So when we isolate the power to the voltage sensor, then the low battery voltage alert will be displayed on the LCD screen, and we can select the normal charging and fast charging. So now the battery is charging with the help of this relays, and whenever the voltage is above threshold value, means it's above 12 volts, till the duration the system keep on this charging circuit through the relay. So this is about the current and voltage measuring. And temperature, so whenever the temperature crosses the threshold value of 45 degrees centigrade, then will get the audible alert through the buzzer, as well as system will on the cooling fan, right? So the cooling fan got switched on, as well as buzzer got switched on. Till the temperature coming to normal, it's keep on this buzzer and the CPU fan. So the CPU fan controlling to this BC547 transistor board, right? So here we are using the main PIC16F73 microcontroller, which will getting input from the sensors as we discussed. Voltage sensor and current sensor interface at the A0, A1, temperature is A2, and pin number B2 to B7 for this LCD screen, and C4 for the buzzer, C6, C7 to this relays, C0, C1 to these two switches, and C2 for the fan. So these are the main interfacing connections of input and output modules, right? Thank you.